Okay, so we're going to be doing here page 98, number 17. And 98, number 17 is says, well, we have this rational function ax plus b over cx plus d. And what conditions are we going to put on the variables a, b, c, and d such that the derivative of f of x, or such that all of the slopes of the tangents to f of x are always positive. So the first thing we'll do is we'll make the obvious, one of the obvious restrictions here and say that x cannot equal negative d over c. That'll give us division by 0 here. This is a vertical asymptote for this function. So what's one of the things that we need to say here is that, well, we're not going to be able to have any positive slopes at our vertical asymptote. So there it is. That's a bit of a domain problem. So we'll just get rid of that. Over here, we'll talk about the derivative. And the derivative is going to take the form a times cx plus d, so that's the derivative of the top times the bottom, minus the top ax plus b times the derivative of the bottom, which is c, all over the bottom squared, cx plus d squared. So we want to know where the slope of the tangent will be positive. So we want to know where the derivative will be positive. So we're going to just talk about this line again. Well, I'll expand in the meantime. Plus AD minus ACX minus BC over CX plus D squared. And we want to know where that's going to be positive. Positive slope of the tangent is positive derivative. So, well, the first thing, there's a couple of things we can see here. So let's assume, well, not assume, but we know that x cannot be equal to negative d over c. Now, if we take that into account down here, if x is going to be any other number, then we're going to have some value squared, some number that is not 0 squared. And any number that is not 0 squared will be positive. So when we divide by a positive number, that does not impact whether or not our number will be positive or negative. So the first thing we can do is we can eliminate the usefulness of this denominator. It does not contribute any information. So our next line, we can just eliminate it. ACX plus AD minus ACX minus BC. Now that's going to be positive. So if we're talking about that, when we look here and we see, well, we've got an ACX minus an ACX. So it doesn't really matter what the values of AC are. ACX minus ACX gives us no more x. That's gone. So all we have left here is that AD minus BC has to be greater than 0. And that's really all the question is going to boil down to, is that's going to be our conditions for A, B, C, and D. If you can come up with an A, B, C, and D such that AD minus BC is positive, then the derivative will be positive, then the slope of the tangent to this will be positive. And okay, so going over to Desmos on this, just to do a little bit of graphical analysis, a function in this form is going to take one of two major different forms when we look at it. And that is this version right here. We have vertical asymptote, horizontal asymptote, and we have curve up, or I'll just pick one of these sliders and do something like this. Or we have vertical asymptote, horizontal asymptote, and goes down, goes down. Now, well, if I were to just take my pen here and approximate some slopes of tangents, we can, if I were to put it here, that slope of the tangent would be negative, this one would be negative. If I move it over here, it'll be negative, that one will be negative. So it looks like under this condition, that all of the slopes of the tangents to this function will be negative. And if we look at my values, then we have AD is a negative value, minus BC is a negative value. But if I'm looking at my values here, this negative product minus that negative product is going to give me a negative product overall. And if I just slide that D value over here like that, now I have positive product minus a smaller positive product. And if I look at my slopes of the tangents, I can see that they're always positive. Now, using my pen to make these slopes of the tangents is a tad bush league, but it's easier to set up on Desmos than making a variable slope of the tangent for that. Anyway, I hope that straightens it out. The actual answer to the question is just that's your condition. AD minus BC has to be positive. That's all we really need to do for it. Thank you.